All right, 2.7 is transformations, which is why you had that little tidbit there. Um, but what this is the transformations of certain graphs. So I'm going to talk about some of the graphs real quick and what we're going to name them. This horizontal line we already referred to, that's the constant function. And this line is the basic linear function where it's passing through 0, 0. I'm a little bit off with some of these, but it should be passing through each point where y is equal to x, and it's called the identity function. So it's kind of going directly diagonal, cutting quadrants 1 and quadrant 3 in basically 45-degree angles. That's the identity function. And we talked about the absolute value function, yes, or in 2.6. And so this is y equals absolute value of x. And this one is y equals a constant. And the last one we're going to refer to is a quadratic function. And a quadratic function is when it has an x squared, y equals x squared. So these are the parent functions of the absolute value, the identity, or linear, and the quadratic, which means it's the most basic function. This is just y equals absolute value of x. There's nothing more. This is y equals x squared. There's nothing more added on to that. If we look at this, some of you may know what this looks like, the quadratic. You've seen it before. If I plug in these values in for x, negative 2 squared is 4, negative 1 squared is positive 1, 0 is 0, 1 squared is 1, and 2 squared is 4. So when I go to plot these, I have 0, 0, 1, 1, negative 1, positive 1. 2, 4, negative 2, positive 4. And it should look like this. Let me try to draw straight. And this is going to be a parabola. A parabola is a graph of a quadratic function. So out of those functions, we're mostly going to be using the transformations with the absolute value and the quadratic functions. And they each have their forms. So we looked at their parent functions and what they look like. All the other functions are going to be based off of that. And they're going to be changed in a way to either they're shifted left or right. They could be shifted up or down, or they could be stretched vertically or compressed vertically. And stretched vertically is going to make them skinnier or more narrow, and compressed vertically is going to make them wider. And we'll talk about that in a little bit. But this is going to be the formula for each of them in there to tell what the transformation is. And each of these variables affect it in a different way. So this A that's out in front is the dilation. And that's what's going to either stretch it vertically or compress it vertically and make it more narrow or more wider. So if that absolute value of A is greater than 1, then the graph is going to be stretched vertically. Both of these are vertically. And if the absolute value of A is less than 1, then it's compressed vertically. The negative has nothing to do with it being stretched or compressed. Okay, that's one thing that's important, because a lot of people will say when it's a negative, oh, it's less than 1, it has to be compressed. And that's not true. You're looking at the number without the negative sign or positive sign. The negative does something else. So if the A is negative, then the graph is going to be reflected across the x-axis. And I'm going to go over an example of each of these on either function. So the h and k will shift the graph horizontally or vertically. And the h is going to shift it horizontally. Now, we're going to use this form for a lot of other graphs as well, and all of these transformations are the same for all of them. So what you need to notice is that you get the h from what's inside with the x. In this case, it's inside the absolute value. In this case, it's inside the parentheses that is being squared. So you get the h from inside with the x, and because it's inside with the x, it's going to shift it in the x direction, left or right. The k is on the outside of the parentheses or the absolute value, and is just being added on at the end. So that's going to shift it in the y direction, up or down. One thing you have to pay attention to is the h. Notice that the h is inside its x minus h. Because the h is minus, you're really going to have to use the opposite sign of the sign that's in the equation that you're in the function that you're graphing, or that you're referring to. So we're going to go over some of the transformations here. You don't have to draw the graphs perfect, just do a quick sketch of them, and just to get an idea of what these transformations do. They don't have to be real big, just so you understand what's happening with each transformation. So this is the parent function for absolute value, and I'm going to say if I'm going to change to red, and if we put the a greater than 0, something like f of x is equal to 3 times the absolute value of x, then what happens is it's going to be stretched vertically. So it's like you're taking the graph and you're stretching it, so it's going to be more narrow. And basically with this one, understand, like for this, my slope, basically this is 2 linear lines, and my slope was positive 1 or negative 1 because of the absolute value. And now the slope is positive 3, rise 3 over 1, or negative 3. Okay, so that's kind of what it changes with the absolute value. Now we'll look at one that is less than 1, say something like 1/2 absolute value of x. I'll squeeze it in here. Notice I still have the parent function in blue, the stretched function in red, and this green one is a little darker than my writing, is in green. And what's happening is it's compressing it vertically, so it's making it go wider than the parent function. And if you notice, again, there's 2 linear lines, and the slope is less than 1. It's rise 1 over 2 in both directions, with the positive slope and the negative slope. And with the quadratic function, it's the same thing. We'll first look at the parent function, f of x equals x squared, which is what I have here. And then we'll take a look at the same types of transformations. Let's say y equals, or f of x equals 4x squared. And if you notice, same thing happened. It got stretched, so it's skinnier, it's more narrow. But also pay attention to this first point. When I plug in 1 here, it's 1 squared, which is 1. So I have the point 1, 1. Well, what happens, instead of that point being at 1, 1, that point is now at 1, 4. So it's kind of like that rise over run, but only for the first point, because it's not a constant. It won't continue at that rate. It is a quadratic. But for that first point, it's rising up 4 and over 1 for that first point because of. And so this time, let's look at one that would be compressed vertically, say 1/3 times x. And if you notice, that would be this green one on the end that's wider because it would be compressed. So that's what that would look like if the a is less than 1. So let's look at if the a is a negative, if it was something like this, negative x squared. And what would happen is, remember, it's reflected across the x-axis. So what it means is it flips vertically, and it would look like this. So instead of going up, it's going down. You may remember it as smiley face when it's positive, sad face when it's negative. And so the same thing will happen with the absolute value when the a is a negative. It just, instead of the v going up, now you have the v going down. So let's talk about the shifting. So again, we'll start with the parent function of the quadratic. F of x is equal to x squared. And so for this one, let's look at shifting, and it would be f of x is equal to x minus 2 squared. So what happens, this 2 is the h, and remember you have to use the opposite sign for the h. So because this is a minus 2, we're actually going to shift in the positive direction 2, which is going to be to the right 2. So it's going to look similar to this. This is what it will look like. Instead of here, it's the same shape. It's not stretched or compressed because the a is a 1. And it's shifted right 2. So the vertex of it, instead of being at 0, 0, now is at 2, 0. And it's shifted right 2. So if we're looking at this green one, it was shifted left 3, and we're trying to write the function for it. Well, because it's shifted left to right, that's going to be the h, what's on the inside. But because it was shifted left 3, what's really happening is that h is a negative 3. So it's x minus h. So that's going to be x minus negative 3. Well, that's really just going to become x plus 3. So we got to use the opposite sign, just like we said before. So because it was shifted left 3, that's going to be in the inside of the function x plus 3. Let's look at the vertical shift, and that's going to be the k. So it's going to be something like this, the absolute value of x plus 4. So this is what it would look like. It's the same shape. It's not compressed or stretched any. It's the same shape. It's just shifted up 4. So the vertex, instead of at 0, 0, now is at 0, 4. So if I'm looking at this last graph, and this green one is shifted down 2, I'm going to write that function f of x is equal to the absolute value of x, same shape, and it's shifted down 2. You don't use the negative for the k, remember, so it's just going to be minus 2. The k is a negative because it's going in the same direction as the graph. Okay, so we're going to do 2 examples with several different transformations happening at once. So in this one, my a is 1/2, my h is 3, and my k is 2. Remember, the h is the opposite sign. That's why I wrote positive 3, which means it's going to shift in the positive direction 3 because you got to use the opposite sign. So I'm going to find the vertex first, and I get the vertex from the shifting. So I'm shifting right 3 and up 2. So my vertex is going to be right here. And all that is the h and k, the opposite direction of what's inside with the x. So that's in minus. I move to the right, the opposite direction, and up 2. And then to get other points to tell whether it's compressed or stretched, this one is going to be compressed because the a is less than 1. And instead of the slope basically being 1, up 1 over 1 in both directions, I'm going to be up 1 over 2. So it's going to be compressed by 1/2. And then I'm going to draw my lines. And I use my ruler, and that's what my new graph is going to look like. It's a little bit wider. It's shifted right 3 and up 2. Why didn't the prawn share his dessert? Because he was shellfish. And this one I'm going to describe the transformations first. So this one is reflected across the x-axis, stretched by 2, And it shifted because this is a positive 4, use the opposite sign, so it shifted left 4 and not the opposite sign for the k, so that's going to be down 1. So I'm going to get my vertex first, and that shifted left 4, down 1. It's reflected across the x-axis, which means it's going to be going down instead of opening up. And it's stretched by 2. So instead of that first point, 1 up, 1 away, or instead in this case, 1 down, 1 away, it's going to be down 2 and over 1. And in this case, it's stretched, so it's a little skinnier than the parent function. And that's going to be my graph.